Fusion Mobile, quality e-learning experience on the go.
Today we are handling a topic called wave. Wave is a branch of physics that treats matter as a disturbance. But defining it, we'll say that a wave is a disturbance which travels through a medium and transfers energy from one point to another without causing any permanent displacement of the medium itself or the particles of the medium. While wave motion is the movement of this particular body or this disturbance which travels through the medium and transfers energy from one point to another without causing any permanent displacement of the particle of the medium. There are two types of waves. We have the mechanical wave and we have the electromagnetic wave. The mechanical wave is a type of wave that needs material medium for its propagation, while electromagnetic wave are those ones that do not need any material medium for their propagation. Example: in mechanical wave, we have example of mechanical waves such as water wave, wave on the spring, sound wave. All these type of waves, they need something to propagate them. While in electromagnetic wave, example, we have light, we have gamma ray, X-ray, ultraviolet ray, and many others. Now, a wave is said to be transverse wave if the direction of travel of the wave is perpendicular to the direction of the vibration causing the wave, while longitudinal is obtained when the direction of travel of the wave is the same as the direction of vibration of the wave. Example of transverse wave: water wave. Water wave. While longitudinal wave, example, wave on a spiral spring. Wave on a spiral spring. Now from there we'll talk about terms used in describing wave. First, amplitude, which is the highest displacement made by the particle in wave. Period, the total time taken to complete one oscillation. That's period. Frequency, this is the number of cycles covered per second. Wavelength is the number. Wavelength is the distance between two successive crests or two successive troughs or two successive particles in phase. Let's represent it with a graph. From here to here is a wavelength. That's the distance between two successive crests. From this point to this point is a wavelength. That's the distance between two successive troughs. Now, if I have a particle somewhere here and I have another particle somewhere here, these two particles are in phase. That means that if these two particles are in phase, that means that from here to here is also wavelength. So we'll say that wavelength is the distance between two successive crests, two successive troughs, or two successive particles in phase. While from this point to the rest position here, this is what we call amplitude. This line is called amplitude. From the rest position to the crest, or from the rest position to the trough. is called the amplitude. While one cycle is starting from here, making a one complete toe movement and making another complete fro movement. So from here, 0 point to this point is considered as one cycle. So the time taken to move from here to here is what we call one cycle or one period. The time taken to reach there is called one period, while the distance itself is considered a cycle. Wave speed. This is the total distance covered by the wave in a given time. Then we now come to another part of wave. Stationary wave or standing wave is a wave obtained when two progressive waves of equal amplitude and frequency are traveling in opposite direction and combined together. When two progressive waves, for a wave to be progressive, it must be moving from one point to another, transferring energy as well. So when two progressive waves, like this one here, two progressive waves, this is one, this is another, both are progressive, they are moving. Two progressive waves of equal amplitude and frequency are traveling in opposite direction. Both are moving in opposite direction and meant to combine. They are meant to combine such that we now have this to be A and this one now is B, while we have this to be B. They form more like a bumble there, and this bumble is what we call stationary wave. A node is a point on a stationary wave where there is no movement. This is a node, this is a node, this is a node at the point where there is no movement. An antinode is a point on stationary wave where there is maximum movement. This is an antinode, an antinode, an antinode. That's an antinode. So from a node to an antinode, we have wavelength lambda to be equal to L/4, while from node to node we have lambda to be equal to L/2. Now, properties of waves. You have reflection, which is the bouncing back or bouncing away of wave particles when it encounters an obstruction or obstacle on its path of propagation. Refraction. This is the change in speed or direction of wave when it's traveling through the boundary of two media of different densities. Diffraction is the ability of a wave to bend around an obstacle. Interference. This is the property of a wave obtained when two waves moving to the same direction are meant to superpose at a point. It can be constructive and it can be destructive, depending on when this interference is in phase or completely out of phase. Then we talk about polarization. Note, polarization is exclusive property of transverse wave. It's only transverse waves that can be polarized. Longitudinal waves cannot be polarized. Now we'll move over to reflection of light waves. But before we do that, I would like you to take a little shift backward. Take another detailed study of what we just finished on waves. Then join me in this class reflection of light waves.